What's going on, guys? In this video we are going to take a look at ASM chart. ASM mean algorithmic state machine. Algorithmic state machine. Now let's go ahead and see how it's going to be. First of all, let's look at the sample step for ASM chart. Here we have a controller, and the controller will have a control input, and for this controller, go to the data path, and for this one we will have a control input, and then starting signals will be coming from data path. Starting signals, and from this one we will have data output, data input, and then ALU at here control unit. Okay, now let's look at the condition to draw the SM chart. Conditions to draw the SM chart. The first condition is, let's write it one. First condition is one and exactly one transition. One transition from every state at one instant of time. The next state is uniquely defined for the input. The next state is uniquely defined for the input. Okay, now let's look at the components. The components, we are going to have input, and also we are going to have the output coming from that output. Let's look at the state box. This is the components. The state books look like this. We will have, actually this is the state box. This is the state box, and this one is conditional output. Here we will have two options. This one can be true or false, or 0 or 1 based on the thing. Here I'm going to put 0 or 1, and also sometimes you will see this one is false. If it's 0, it's a false, and if it's 1, it's true. This is the decision box, conditional decision box. Okay, now let's look at the rules of SM chart. Rules of SM chart. For any valid input, there should be valid exit path. For any valid input, there should be valid exit path. There should be valid exit path. The second one is there should not be any feedback within this same block, SM block. There should not be any feedback within the SM block. Okay, now let's go ahead and continue here. Now if this is state diagram and decision box, and if it goes like this here, it's wrong, because it should go to the box. This is our decision box. It should go from here to here. Okay, this is the correct way to do that. Now here we are going to look at two machines. One is melee machine and the other one is mode state machine. Okay, let's see how to draw the ASM diagram for those. Okay, machines. We have two type of machines. One is melee machine, and the other one is more state machine. Now let's go ahead and draw the melee state machine. It's S1, S2, S0 right here. This one is 1, 1, and then 1, 1, 1, 0, zero, 1. Okay, now let's write the conditions. Output is the function of present state and input. Output is the function of present state and input, and conditional box is used only in melee state diagram. Conditional box is only used in melee diagram. The conditional box is basically the oval shape box. This is only used in melee state diagram. This is only used when we have the number that is greater than, if we have the output that is greater than 0. For example, if it's 1, we use this one. Okay, now let's see how to draw the ASM chart for this. Okay, first of all, here you can see this is a single input, because if you see 1 backslash 1, it means just a single input. If it's single input, we just put X. If it's, sometime you see we will have 0, 1, comma, 1, 0, something like that. If it's like that, it means double input. In that case, we have to use X and Y. But for this one, this is just a single input. So I just put X right here. And let's look at the conditions. Okay. So basically, if you have 1, 1, it means when S2 is 1, it goes to the S1. But here we start from S1, let's start from S0. Here we have S0. In S0 it says if we have 0 and it goes back to S0, like let's draw the decision box. We have X and it can have 0 and 1. And here it says if the S0 is 0, it goes back to the S0, but it's 1. If it's 1 mean we have to use the conditional box, because conditional box is used when we have greater than 0. So since we have 1 as the output, this is the output, the first number is input, the second number is output. If you have 1 as the output, we have to throw this conditional box right here. And in this conditional box we have Z, we will always have Z, and this one goes back to S0 for the first thing. Now let's look at the next one. Next one state when S0 is input is 1, the output is 0. So S2, let's look at the S1 here. S0 doesn't go to S1, so let's not worry about that. The next thing is we are going to have S1. I draw the S1 box right here. For the S1, this one is also 0-1, and this one also 0-1. If it's 0/1 means 0 is the input, 1 is output. So decision box, everything will have decision box. In this decision box, here we have 0, this is 1, and if it's 0-1, it means the output is greater than 0. So we have to have a conditional box like this, and inside this we will see, and it goes back to S1. Okay, now S1 is like that. Then if S1 is, the input is 1, then output is also 1. So input is 1, then output is also 1, mean we have to have again, it goes to S0. So output is 1, mean we have to put a conditional box and Z inside, and it goes to S0. S0 is here. Okay, it's connect like this. Okay, now we have S0. Now let's see what happens to the S0 if we have 1 on X0. If S0 is 1, S0 is 1 and the output is 0, it goes to S2. Let's draw the S2 right here. This is S2. We always have to write it outside. S1, S2. Okay, now what? S2. Okay, S1, S0 has two conditions. S0 can be 0 and S0 can be 1. If S0 is 1, it goes to, if the input is 1, the output is 0 and goes to S2. So it should go here. And then let's look at S2. S2 has, if it's 0, if the input is 0, output is 1, and it goes back to S2. Let's look at the decision box. X right here, we have 0 and 1, and if the input is 0, output is 1. Output is 1 mean we have to draw the conditional box inside of the Z, and it goes back to S2. Now if the input is 1, the output is also 1, goes back to S1. If the input is 1 and the output is 1 and goes back to S1, so we have to draw a conditional box because output is greater than 0. So conditional box right here inside of this on Z, and it goes back to S1, and that's it. That's how we draw the melee machine. Now let's look at how to draw the Morse state machine. Okay, now let's get rid of this one. Now I'm going to draw the more state machine. More state machine. Let's look at how A over 1, C over 0, B over 0. Okay. Let's draw this like this. And here we have 1 1. This is 0 1 1 0. And here we have 0 0 0 0. And then this one is 1 1. This is 0 1 1 0. 0 1 1 0. And here it is 0 0. And this one connected to this one right here. Actually, this one goes in, this one comes out. This one goes in and this one comes out. And here this is 0 1 comma 1 0 and this is 1 1. Okay. And here we will have 0 0. Now let's go ahead and continue here. Output is the function of only present state, not input. Output is the function of only present state, not input. Only present state, not input. Okay, now let's go ahead and draw the diagram. Z is equal to 1, Z is equal to 0, and then Z is equal to 0. Okay, now everything has two choices. Because you can see this is two input, so we will have X and Y. Before, in the mealy state diagram, we had one input. If it's one input, it usually comes like this, 0 dash 1. But if they just put 1 1, it means it's two input. For most state, it's a two input, so we had to put X and Y as well. And it doesn't have the conditional box because it only comes for mealy machine. Okay, now let's go ahead and continue. X, Y, the input is here, and the conditional, here we will have the this box, the select box. This one is called actually the decision box. For this, if you have two input, it divide into 4, because if you'll see, if we have X and Y, there are four possibilities: 0 1 0 0 0 0 1 1 0 1 1. Okay, so this is X, and here we will have Y, and also Y right here. And this is here is 0 1, and this is 0 1, and here 0 1, and okay, let's avoid this. Everything has this same decision box, X, and then we will have Y right here, Y right here, Y right here, and this is 0 1. Let's erase this one for now, because I'm going to draw based on the diagram. I'm going to explain one by one. Okay, this one 0, this one's 1, and this one 0 right here, 1. And again here we will have a decision box X 0 1, it has a branch Y, it also has 0 1, and here again another branch Y, it also has 0 and 1. Okay, now first let's look at A. This is box A, this is B, and this one is C. A is, if it's 0 0, it goes back to A again. So if it's A, it goes right here. And if it's 1 1, it goes to C. If it's 1 1, it goes to C. And after that, in the C, if it's 0 0, it goes back to C. If it's 0 0, it goes back to C. And then if it 1 1, it goes to B. 1 1 mean X is 1, Y is also 1. It goes to B right here. And then we have, okay, if it's 0 1, A is 0 1 1 0, it goes to, no, if it's 0 1 1 0, C goes to A. 0 1 1 0 mean the middle part, this middle part is a 0 1 1 0. If you have two of these things, it's always the middle one. It goes to A. We can connect it here. Now if A is 1 1, it goes to C. We already did that. And if C is 0 0, it goes to C again. We already did that right here. And then if the B is 0 1 1 0, it goes to C. B is 0 1 1 0, it means it's the middle part, it goes to C mean. We can just straightly connect this one right here. Then if C is 1 1, it goes to B. If C is 1 1, it goes to B. I already did that. And B is 0 0. If B is 0 0, it goes to B. 0 0 is here, it goes back to B. So it connects like this. And then if B is 1 1, it goes to A. If B is 1 1, here it goes to A. Connected like that. And then if B is 1 1, it goes to A. And that's it. That's how we draw the Moore state machine. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn digital logic design 2 or computer architecture, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.